Good morning, students. So today I'm going to help you solve this problem. I'll show you how to solve this problem, which is an example of what you will be working with for the week. As reference, here are the problems. I'm solving number 54 right here. All right, so what we're doing is we have to, as always, find the value of x, right? Solve for the variable in the interval between 0 and 2 pi. It's pretty much the same thing we've been doing. So how do we solve these kinds of equations? Well, this one is actually pretty simple. We just have to say that one of these is equal to 0 and then take the other one to be equal to 0. Because if you look at it, the only way that these two being multiplied can be equal to 0 is if at least one of them is equal to 0. Right? So if sine of x minus 1 is equal to 0, then when we multiply it times this, regardless of the value that we have here, it's also going to be 0. Okay? And likewise, if the tangent of x plus 1 is 0, then it doesn't matter what we have here, it's also going to be 0. So if it's already factored this way, then all we have to do is take 1. The tangent of x plus 1 must be equal to 0. Then we take the 1 to the other side, and look at that. We are almost done. We just started and we're almost done. So the tangent of x must be equal to -1. You should already know this by now because we've done this so many times, but just in case, using our unit circle, we see that the tangent, remembering that tangent is sine over x, sine over cosine, or y over x. So y over x, this would be equal to -1. This would be equal to +1. We're talking about tangents here. +1 as well, and -1. So which of these angles are equal to -1? Only 3 pi fourth, which is this one, and its other corresponding angle, 7 pi fourths. So we already have two values right here. So x1 must be equal to 3 pi divided by 4. x2 is equal to 7 pi divided by 4. And then we do the exact same thing with sine. So sine of x minus 1 must be equal to 0. We take the 1, we put it to the other side. Sine of x must be equal to 1. And we see here, remembering that sine is the y, the only place in all of our unit circle where the sine is exactly +1 would be right here. Okay? This is -1, 0, 0, and a bunch of other numbers that are not 1. So the only place where sine of x is equal to 1 is in pi halves, or 90 degrees. So we have a third value for x, which would be pi divided by 2. And we are almost done. Now, we're missing one small step, which is a crucial step. You have to always verify your results. Okay? So for example, if I have tangent of x1, 3 pi divided by 4 plus 1 multiplied by the sine of 3 pi divided by 4 minus 1 must be equal to 0. So this is 0. We already know that. That's fine. We don't have to do it again, right? So tangent of 3 pi fourth is equal to -1. That's why we chose this angle. -1 plus 1 will be equal to 0. So in here, there's just not too much. However, now we have to verify, well, basically what we're doing is we're verifying these angles in the other trigonometric function. It is very important that we do that because some trigonometric functions are undefined. Okay, I'm gonna write it right here. Undefined at certain angles, which actually happens in this problem. That's why I chose it. Not with sine. With sine, if we go over here, sine would be equal to negative 2 divided by 2. I mean positive, sorry, it's y. Positive 2 divided by positive square root of 2 divided by 2, and it would still be 0. I mean, minus 1. It would still be 0 regardless, but we just have to make sure that the sine of this angle exists. In this case, it does. As a matter of fact, sine is definite at any angle, right? So we have no problem with sines. But tangent, tangent brings problems. So the tangent of pi half. Why would we have some problems with that? What? I don't get it. Why? You must be wondering. Well, allow me to illustrate. The tangent of pi halves, as we always know, will be the tangent y divided by x. Some of you must be like, oh yes, I see. Many of you are like, man, I don't know what the heck you're talking about. I know. So the tangent would be y divided by x, which in this case y is 1 and x is 0. Do you see where I'm going now? We are dividing by 0 because the coordinate is 0, 1. So the tangent of pi halves is undefined because we cannot divide by 0. Therefore, when we are expressing our results, we cannot say that these three numbers are our results. The only ones that we can consider our results are these two, because our function of tangent is not defined in this result. So x, right here. So x must be equal to 3 pi divided by 4 and 7 pi divided by 4. These are our results. We exclude this one because it is undefined in tangent. All right? And that's it. That's our problem. So, real quick review. Once we have our functions in this form where they are multiplying or factored, we just make each one of them be equal to 0. Extremely important, guys. It must be equal to 0. If it's not equal to 0, we cannot do this. All right? I'm going to do one more example real quick. Hopefully this will be less than 10 minutes. And then, yeah, that'll be all. So let's go real quick. So the second example I want to work with is the, or what's it, 59? Yeah, let's go with 59. So 59 is sine of x plus 2 sine of x cosine of x must be equal to 0. So whenever we have a problem like this, our first step will be to factor it. Okay? These two are the same. So we factor it. Sine of x must be equal to 1 plus 2 times cosine of x equal to 0. And what we're left with is, once again, two different ways, let's say. Sine of x must be equal to 0, and 1 plus 2 cosine of x, I messed that up. 1 plus 2 cosine of x must be equal to 0. You see? So once again, the sine of x, the only angle that can be equal to 0, well, not the only, there's two angles. There will be x1 would be 0 radians, and x2 would be pi radians. This you can do it from your unit circle. And here we take the one to the other side, 2 cosine of x. If you need to pause at any given time, you are welcome to do so. And then we divide by 2, the cosine of x is equal to negative 1/2, and then we do the same thing. I'm sorry I rushed that at the end. I wanted to make this video less than 10 minutes so it could be uploaded as a single video. From here, x, we already know, you can use your unit circle, you can solve it. And don't forget to verify your